The last type of problem asks us to classify each system. So remember, there's three different types of systems that we have. So down below, I'll write down those three types. Three types of systems. And so remember, we can have one where we have lines where they intersect. And so there's one solution. And so you're going to end up getting an answer for x and y, whatever that is. So that's one type. And so the other type is when we have lines that just never cross. We call these parallel lines that don't cross. And if they are parallel, that means we have no solutions. So that means they're not going to end up crossing, and so the symbol we use for that is just a 0 with a slash through it. And that is when we end up with an answer that looks like this. All the variables cancel, and you have, like, let's say 3 equals 4. Well, 3 doesn't equal 4. And there's no other variables there, so that's when basically the y-intercepts are the same, but the y-intercepts are different, but the slopes are the same. So that'd be a no solution. The last type is when we have one line, and then you've got another line that just lines up right on top of it. And so if we have that situation, that means we have the same line. And if they are the same line, it means they end up having an infinite number of points. And so we say the answer is infinitely many solutions. And there was a symbol that we used for infinite, and it's that sideways 8. So those are the different answers we're going to end up coming up with, either a one solution, parallel lines, no solution, or infinitely many. So let's see what we get on these problems here. So that first part, I'm going to go ahead and use a substitution with this one. This is a good method for substitution. Put that in place of that y, you've got this, 3x minus 7 equals 3x plus 2. And so when you go ahead and solve this, you're going to move that 3x over to the other side, and you see it cancels out. So whenever your answers cancel, you're going to have one of these two types, either parallel lines or same lines. So we just have to work further to see what the answer is going to be. And so here we have negative 7 equals 2. Those two numbers do not equal, so that means we have a no solution. That means we had parallel lines is what we had there, and they just don't cross. Well, let's take a look at our next one here. This one's another good substitution problem. Take that expression, put it in for y, and we'll see what we get. So we'll go ahead and rewrite our top equation, x plus 1/2 of y, which is negative 2x plus 6. And we go ahead and do that work there. Distribute that 1/2 over that subtraction, because they are opposite in sign. We end up with this, x plus, actually it's going to be x minus, because we have a negative times a positive. So x minus, and then the 1/2 of 2. Half of 2 is 1. So you get 1x, and then 1/2 of 6. That's 3. See, I show you up here. 1/2 of 2. The 2's cancel out and make 1. 1/2 of 6. Well, the 2 goes into 6 3 times. You multiply across. That's how you get 3. Equals 3. Well, the x and the negative x, they cancel. So whenever they cancel, again, it's either one of these two. This time we end up with the numbers equaling. If the two numbers do equal, that means we have the same line. So that one we call infinitely many solutions. So many solutions because all the points on each line represent a solution. And there's an infinite number of points on a line. And so that's why we say there's infinitely many number of solutions. So those are the types of problems you'll end up seeing. Good luck on tonight's homework.